Okay, so the last little topic we're going to talk about kind of still involves formal charge calculation, but now we're going to try to talk about carbon. So carbon is going to be the main facet of what we talk about in organic chemistry, so it's going to be really important for you to get used to the charges of carbon and how you can potentially see carbon drawn. Okay, so this is one potential way that you can potentially see carbon. So CH3 with a positive charge on it. So go ahead and pause the video and see if you can draw this type of cationic structure for carbon. All right, so hopefully this is the structure that you got. If you think about the overall charge of carbon, and if we were to do a formal charge calculation, this carbon would have a total valence of 4. That's another very important number to memorize. So it's going to have 4, and then right now we have 3 total bonds, and we have 0 lone pairs. So right now we're going to get a total charge of +1, and this guy in the middle does have a +1. So this is one way that you'll see carbon. So this carbon again does not fulfill its octet. So if you think about the total number of electrons, we've got 2, 4, 6. So we're not really fulfilling the octet, but it's very important to recognize that we're not breaking any rules by keeping this oxygen as it is. So we're not breaking the octet rule, but the octet rule isn't really being fulfilled. And it turns out that in real life, this kind of carbon structure can actually be made, and it's not impossible in any way, shape, or form. Okay, so this kind of positively charged carbon can exist, and we'll talk about different positively charged carbon structures later on. Okay, so go ahead and draw another form of carbon. This guy should be pretty simple, and then let's try to draw a third carbon structure like this. Okay, so go ahead and pause the video and try to draw these two structures. So for this carbon in the middle, you were given the fact that this carbon has 0 charge, and if you actually look at this way you could draw the carbon, so this is your carbon in the center, and what we're doing for all of these examples is if the carbon is kind of in the center location, you can kind of do a little bit of shorthand to get away with not drawing that carbon out. So if I wanted to draw the carbon in the center, I could totally do that, but one thing you'll see me kind of go back and forth is either A, drawing the carbon like this, or just kind of understanding that you will understand that if you have a point, then this carbon is going to be, understood. So it's kind of an implicit carbon, so it's just something to be aware of. So if you think about the formal charge for this guy, we'll have valence of 4, and then -1, 2, 3, 4, and then 0 valence, or 0 lone pairs. So in this case, this charge is 0, so this guy checks out. And this is a very common way that you'll see carbon for the rest of the course, is a neutrally charged carbon with 1, 2, 3, 4 bonds to it. So get used to this kind of structure. Okay, so if you haven't quite finished this one, pause the video again, but if you have, just keep on listening. So this carbon right here, there are a couple ways you could try to draw it, but the main point is that you have a carbon that seems to be bound to 3 hydrogens. So we're going to talk about these wedge and dash notations a little bit more detail later on, but just for now, this is just a way that will show a little bit of three-dimensionality to the carbon. But for now, you can kind of ignore them. So this is our carbon. Again, this carbon in the center is right here, and it's kind of understood that this is a carbon. You don't have to draw the carbon out. Okay, so now thinking about the carbon's charge, if we want to do the formal charge calculation, we do 4 minus 1, 2, 3, 4, 5, minus 5, minus 0 for the total number of lone pairs. So right now, if you do the calculation, you'd see that this carbon in the center does actually have a negative. And this looks to be not too bad until, again, you start thinking about the octet rule for the carbon. So again, this carbon has, if you count all of the electrons that are surrounding it, we have a total of 2, 4, 6, 8, 10 electrons. So these 10 electrons are exceeding the octet rule, so this molecule actually will not ever exist. It's impossible for carbon to get this kind of configuration. So you can actually have a negatively charged carbon, but it's going to show up a little bit differently. So we could draw carbon with a negative charge if we drew it something like this. So if we think about the formal charge on this carbon, this seems to be okay. So let's go ahead and draw our carbon in the center, and we've got 1, 2, 3 hydrogens attached. So now for this molecule, we can make this carbon negative if we actually go ahead and try to fulfill the octet rule. So again, right now we have 2, 4, 6, and if we fulfilled the octet rule, we could, put another lone pair right there. And what we'll see in a second is that that carbon will become negative. So if we go ahead and do the calculation, it's going to be 4 minus 3, and then we're going to subtract 2 right here, and that's going to equal negative 1. Okay, so this carbon is negative, and this is one way that we'll see carbon acting as negative, as a negative compound in some of the other aspects that we talk about. Okay, so now you just saw 3 different ways you can draw carbon, either positive, neutral, or negative. And you are now very, very aware to try to stay away from this kind of octet rule violating structure.